Now that we know what the force of gravity is, we want to look at some applications of the force of gravity, and one of them is going to be orbital mechanics. So being able to predict the orbit of an object. And so we're going to go all the way back to the year 1609, when a scientist by the name of Johannes Kepler came up with his laws of planetary motion. So just like Sir Isaac Newton came up with 3 laws of motion, Kepler came up with 3 laws of planetary motion. And so his first law is going to be the orbits of the planets are elliptical. So in this picture here, okay, so there's an ellipse. So how do we define what an ellipse is? An ellipse is going to have 2 focuses, or 2 foci, or 2 foci, depending on your math teacher. So if I draw a line through the middle of this thing, then I could have a focus, F is right there, and then here's another focus located over here, and you could actually draw an ellipse if you have a piece of cardboard paper, and then 2 thumbtacks, and then a piece of string that you're going to stretch out and then attach to the 2 thumbtacks. And then put your pencil in there, and then you can make an ellipse. Then it's kind of interesting what happens to the ellipse if you take the 2 thumbtacks and you move them closer to each other. Well, then what you're going to find is the ellipse is not as stretched out as it once was. And can you imagine what would happen if the 2 thumbtacks, you put them in the middle of the ellipse? So what happens to the ellipse? It turns into a circle. And then the 2 focuses will be here in the middle. So a circle is actually a special case of the ellipse. Now this is going to be the planet out here. So this planet is in orbit around the star, which is going to be here. Now in actuality, that's not quite true. So we're not going to make it too difficult, but Sir Isaac Newton showed that these 2 objects are actually in orbit around their center of mass. So the focus is where the center of mass of these 2 objects is located. But since a star is normally thousands, if not a million times bigger than the mass of this thing, then that means the center of mass is thousands, if not millions of times closer to the star. So for all intents and purposes, the star stays put, and then it's the planet that is moving around it. Okay, so I'm not going to test you on that, so let that ooze out of your head. Okay, there it goes. Okay, feel better? I hope so. But you definitely need to know that a planet goes around a star in an ellipse. Okay, so that was his first law of motion. Okay, let's take a break, and then when we come back, we will talk about his second law of motion.